Okay, so I decided to start assembling that Datsun, and I don't think I'm going to sell it because I knew once I get going assembling it, I'm not going to want to sell it. So this block, I worked on this block in 2012, and it's been lying there ever since 2012. So this racing parts came from a rally car, which over revved and it snapped a conrod. So the conrods that were in that car were for an L14 Datsun, which are slightly longer conrods. I don't know why they chose to use longer conrods. These are the original conrods, which are, I think, 2mm or 4mm shorter than those L14 conrods. These are original Datsun Triple S conrods. So they had those L14 conrods, a little bit longer conrods with the stroker crank. This is a stroker crank, and then this is the original Datsun crank, 1600. So if you look here, this throw, this offset, this is where the conrod sits. This is where the main bearing sits. So you can see that this here, the distance from there to there, the throw is not that much. Whereas if you look at this one, it's a little bit further. So this raises the compression. So I think that's why that other conrod snapped, because normally when you increase the throw, you're supposed to shorten the conrod. So what we've done is we couldn't find the L14 conrods, fortunately, because one of them was broken. Remember, it snapped. So we've decided to go with the original conrods, which are a little bit shorter and stronger, so they're less likely to snap, which you're supposed to use a shorter conrod with a stroker crank, right? Now, because of that, the piston was short, 4mm from TDC. So what we did is we cut the top of the block. We skimmed the top of the block. So these pistons are 2-liter pistons. They're V6 Nissan racing pistons. So now what we're going to do is once we've assembled it, we can measure the CCs and we put the head on. So this is the vernier pulley with the ground camshaft. So it's got a rough idle. And these very, very big valves. They're almost double the size of the original. So you can see there where it over revved and it damaged. So we've had this fixed in Rustenburg at the engineering shop. This was the one that snapped. So it's got big valves. It's got a GT ground camshaft. And it's got the vernier pulley, so we can set the timing if we want more torque or less torque. So what I'm doing now is I've put the crankshaft in. And one of these caps was tight. So what you do is when you tighten all of them and you turn the crankshaft, you see it's tight. Then you loosen all of them and then you tighten one by one. So you tighten one, you turn it, you see, okay, it's fine. You leave it. You tighten the next one, you turn it, oh, it's tight. You loosen it. You tighten the next one, you turn it, oh, it's fine, you leave it. Tighten the next one, it's tight. You loosen it. So this one was tight and this one was tight. So what I've decided to do is I've mic'd the crankshaft. So these guys who originally built this engine, Lamco, they're in Joburg, in Edenvale, I think it was, that rally car. It seems like they're over polished, or they didn't grind it properly. So this one here, it's not going nicely. This is the one that's tight. This one. So this one's tight. When I drop it on here, it goes down nicely. Maybe it's moved, but and this one's tight. So basically, I have to go to the engineering shop to get them to fix this, because we cannot have tight bearings. When you torque these caps, this crankshaft should spin easily, because we don't want that friction there. It will run a bearing. So that's what I got to do first. Then once I can get the camshaft to turn easily, then I can assemble the motor. So there it is. I'm going to be assembling this Datsun Triple S. It's rebored to a 2-liter. These are 3-liter pistons. So each Each piston is equal to 500, half a liter, basically, 500 cc's. But remember, we've shortened the stroke by cutting the top of the block. So therefore, it might be 450. So it might be 1.9 liter, 1.8 liter, 1.85 liter, something like that. So there's a way to measure. You fill up you put everything in, you put the piston in, you put the thing up, and you fill it up with liquid, and then you measure the liquid that comes out, and that's how you get your cc's, cubic centimeter. So yes, here we go. It's going to make a hell of a noise.